Okay, for this next part in 6.2, we are going to look at different functions that have the natural log e in them, and we're going to discuss how to tell if that function represents exponential growth or exponential decay. And then we're going to graph the function. So last section in 6.1, when we were looking at functions that were in the form y equaled b to the x, it was really simple. In order to tell if a function was growth, we just saw if b was greater than 1. And if it was decay, b was just less than 1. Now, here, very similar, except now we've got this term e that's our base. And we have to look at things a little bit differently because now the way to tell is with our exponent rather than our base. So what we're going to look at right here, I'm going to go to the journal and show you one of our core concepts. Here we've got, with natural base functions, I'm going to zoom in here for a little bit. When we have a function that's in the form y equals a constant, times e to the rx power, we call this a natural base exponential function. So again, here we've got a times e to the rx power. So x is our variable and a and e are constants. Now we've got a couple different options that we can have for our constants. First of all, we're only going to look at functions where a is greater than 0. Okay, we're only looking at functions where we've got a positive constant in front of our e value. Now, there's two options then that we have. Either our term that we're multiplying our variable by is going to be positive or it's going to be negative. It's either going to be greater than 0 or less than 0. So if we have a positive value for r, so if our exponent's positive, this is going to be an exponential growth function. If our exponent is negative, then it's going to be an exponential decay function. So basically the graphs right here show the basic functions y equals e to the x power, so our exponent is positive, and y equals e to the negative x. Our exponent is negative. So here we've got our growth, and here we've got our decay. Basically, we're just looking at natural log or natural base exponential functions with a positive coefficient. E is our base, and we've either got a positive exponent or negative exponent. So let's look at this problem right here. We want to determine whether each function is growth or decay. So here we look at and we determine that our a value in this is the constant in front of our base. So here a is equal to 3. And in this case, what are we multiplying our variable by? In this case, we just have x. So in this case, r would be 1. We notice that this is positive. So because this is positive, we know that this is going to be an exponential growth function. Again, we've got a equals 3 and r equals 1. So exponential growth. Now, when it comes to graphing this, like we did last section, we just want to use a table to graph the function. So let's go ahead and we'll just pick out the values -2 up to 1. And when we plug in our values, and you use a calculator for this, you just take e to the -2 times 3 gives you 0.41. E to the -1 times 3 is 1.1. E to the 0 is just 1 times 3 is 3. E to the first power times 3 gives you 8.15. You plot these on a graph, and you'll see you get this fast growth right here. Remember, E is roughly 2.718. So this is just like 3 times almost 3 to the x power. So that's going to be a pretty fast, pretty steep growth. Here, we've got e to the -0.5x. Now in this case, our a value is just 1 because there's no number in front of e. and our R value is negative 0.5. So remember, because A is 1 and R is negative, this is an exponential decay function. Now again, to graph these, we're just going to take some values and plug them into a table. Our normal values that we pick. Because this, we want to get a little bit further out. Otherwise, if we stay too close to 0, we're not going to get enough to tell us what the graph looks like. So we're going to go out by 2's, go to -4, -2, 0, and 2. And we're going to see, again, remember, as we start going down, because this is decay, as we start getting further away from our y-axis, this is just going to get closer to y equals 0 here. So our growth comes down at a steep curve and then starts to flatten out once we start going away from 0 in the positive direction. Okay, so remember, with trying to see if an e function, a natural log function or natural base function, is growth or decay, you're looking at the sign of your exponent. If it's positive, it's growth. If it's negative, it's decay.